Yeah, I mean, there's been some good talks this morning, and I was thinking about the first one and like the stages of AI. And I was thinking like, okay, stage one, stage two, on what stage is actually making tasty alcohol? And since we're in Finland, I assume it's at least 10, but you can let me know. But so that's what we're sort of exploring today. To get us started, this is sort of what I've been seeing in the field. We started off machine learning with trying to automate all of the stuff that humans do or are complex or are something that machines are apparently much more better at. So we started making segmentation stuff, some batch dynamic pricing, recommendations engines, robotic process automation, and so on. But what we're going into is more, how do we augment the sort of creative experts or the decision maker or stuff we do in space and robotics. And this is not like, we're not trying to get rid of jobs and get rid of people doing that stuff, but we're trying to augment their current capabilities. And that's what we're going to talk about today. And especially, we're going to talk about AI-assisted creativity. It's not a new topic. We've made art with machine learning, which sold for over $400,000 at Christie's, which was, I assume the creators were pretty pleased with that. We can do transfer learning, meaning that we can input 2 images to create new stuff. We can do music. And we can actually do pretty good music. There's Beatles generators, there's Metallica generators, there's even a deep jazz generator if you want to do dinner music at home that never stops. It basically generates new jazz all the way along. And we can generate consumer products. But the problem is, and what we're seeing is that creating the sort of core of a complex consumer product, which is usually the sort of recipe or design, is far from trivial. Because we need to make something new and not try to predict something from historical data. And there's like this controversy that we're trying to compare machines with humans. And I think this was relatively funny. A machine was perceived to be as human or like a human because it was so bad at writing poetry. So this is sort of, we don't want that sort of contradiction. We don't want humans versus machines. We want humans plus machines, and let's do something that augments one another. So the talk today is about AI-generated product recipes, meaning that let's do complex consumer products with machine learning. What we're looking for, or what I'm sort of aiming at, what I want to happen is for the creative expert, which is in this case, because we're making whiskey, is the master blender of the company, is to say that, oh, that's nice, I wouldn't have thought about that myself. Like, let's try to create something within the creative process that people perceive as really good, but that's something that the creative mind wouldn't have thought about. And we do it for 3 main reasons. One is, let's try to make great products. The second is, let's try to, at the same time, understand what appeals to customer segments, and then let's try to find new ways to serve small segments. And I'm going to give you an example of the last one later on this speech. The basic idea of machine learning is that we learn features. When we're making whiskey, we're trying to blend casks. And if you think about, there's 75 casks, and that's the sort of relative correlation on how well a specific cask seems to correlate with people perceiving it as good. And If we would sort of solve this problem with just learning features, it would say that, okay, let's use Cask 10 and let's use Cask 2 and mix those and you get a great product. But the problem with complex consumer recipes is that you cannot possibly mix that. And even if you do, you're going to create the same stuff all over again. So you cannot really do that. But you can learn features to try to understand how the problem works. What we actually want to do is, let's call it controlled examination. We need to intelligently limit the sort of infinite space from which we can create. We need to sample from that space, and we need some sort of critic model to understand, is it good or is it not? And that's the main process. And this is really different from learning features, because we're not trying to learn any features, we're trying to examine from spaces and then to critic against that. So, to make whiskey, we started off with 75 previous recipes that they have bottled, and for each recipe we knew that did it win any awards from the competitions it was entered to, what were the internal reviews and possibly even tasting notes, what were the user ratings. There's whiskybase.com and all of this sort of different sites from which you can gather all this data on how people perceive the product. So we started structuring that. So first of all, we needed to understand what is good. And there's a problem because good is sort of relative. There's uncertainty to stuff being good. And let's say that there's vertical uncertainty and then there's horizontal ones. That means that for like any of your products, if there's a lot of different reviews for that product, it's horizontally pretty certain in a way that we can know that it's good. If experts say it's good, if consumers say it's good, if it sells well, it's pretty good. If only experts say it's good and anything else is controversial or missing, we cannot say it's horizontally pretty sort of certain. Then there's vertical uncertainty, meaning that if one expert has only tasted one whiskey and rated that, we cannot really value that against the other whiskeys. So, vertical and horizontal uncertainty. Then we need to figure out weight, meaning that what do we want to actually achieve? Do we want to make a whiskey that tastes best for experts or the brand itself or customers, or do we want something that wins awards? And this is something we need to ask. And from that, we can make a score. And let's say one recipe is like, it's 85 points plus minus 2. Another one is 81 points plus minus 10 because there's a lot of uncertainty going on. And this is something we need to understand and figure out while we are doing the generative modeling. Problem 2, how to choose a cask. So you can think about this. Here's 100 casks. And now your job as a master blender is to pick from 1 to 20 out of them and decide how much you will use so that you create a perfect whiskey. And quickly you'll find out, because you're smart people, that that's an infinite amount of possibilities. So that's what a master blender does. And based on expertise and experience and tasting notes and so on, she's going to say that, okay, by mixing these stuff, we can make good products. For computers, it's a bit different. You know that recipe A was sort of well received in the public, but it's not well received by experts. Recipe B was vice versa. Then you realize you're a computer nerd and you cannot actually taste the whiskey, which makes the process a bit more difficult. And because we're using machines and there's an infinite amount of possibilities, we don't have the capacity to solve this just by brute forcing it. So, what did we do? There's 3 sort of main things. And the easy one was like for certain casks, we know that this is from internal reviews and ratings, we know that some casks we can just leave out, which leaves us from like 40 casks out of 75. Then by some logic, we need to learn what's the brand style, because even though we need to create new products, we still want it to look and feel and taste like something that the brand could have done. We don't want to do something that's completely the sort of polar opposites of what they have made before, because otherwise they're going to lose their sort of really trusted consumers and customers. And then intelligent subspaces of infinity, which means absolutely nothing when you say it, but basically means that from the infinite amount of possibilities, we need some logic with machine learning to come up with like what's the even possible, like let's say 500,000 or 5 million recipes that we could try out. So let's try to leave out infinity and come up with some sort of intelligent subspace of it. Third problem, how to choose an amount. It's basically the sort of same thing we did for the uncertainty. So we know that previous recipes have used, let's say, one particular cask for 30% of the recipe, or 40%, or 2%, or 5%, which gives a sort of a lot of variance in how much we could possibly use it. But this is like, again, this is limiting the sort of infinite subspace and trying to understand that, okay, for certain casks, they seem never to use it above, let's say, 5%. But let's push the sort of envelope a bit and let's say 7%. So let's try to find out what's the sort of deviation and what's the sort of normal curve in which amounts are used per cask. Last problem, you have three problems, which is what's good, how to pick a cask, and how to choose an amount. And then we need to wrap it up in a sort of creative process that's something that humans could do. And this is going to look awful, but bear with me, I'm going to walk you through it. This is the generative modeling process, and you can now just copy it, and you can do sneaker designs, you can do new consumer products with chocolate or beverages or anything that has a recipe with the same logic. This works like humans do. Us as humans, if you write an email or you write an article or you write anything or you do anything sort of creative, you write something, then you look at it and you're like, okay, this is shit, I'm going to start over. Or this is pretty good, I'm going to continue upon it. Or this is okay, but I need to twist some of the things I did. This sort of works in the same manner. Because we want to avoid the learning features thing, we don't want the generative part to actually know anything about the consumer reviews and the expert reviews and so on. We want to hide that information and leave it to the critic only, meaning that the generative part can actually explore new spaces, because if we would reveal what we know about the features being learned, it would just converge to previous recipes. So we cannot disclose that information, which means that there's like a gap minder right between here. So the generative part, it picks a cask, right? It chooses an amount from some intelligently chosen subspace. It sends it to the critic, and the critic says, is this worse or better than what you just did before? If it's better, you get to continue upon that recipe. If it's worse, you fall back to the previous one. Then we iterate this for around 100 million times. Then you start to see it converging. That, okay, I cannot come up with a better whiskey recipe anymore. And crucially, we don't let the generative part know what we actually learned from the scoring, to make it actually explore new spaces. And this also means that from this particular model, you can never design the same whiskey again. When I press play again, it's going to come up with something new. It's never going to come up with the same thing. And this leaves us with a lot of opportunities, right? Because think about a whiskey bar where you could press a button and you would get your own perfect, completely unique whiskey. In the age of sort of personalization and people looking for uniqueness, that's a cool sort of proposal to have. You can even say, like, give me a unique one, but make it smoky. Fine. You get a tailored whiskey on your hand. This is sort of what it looks like. This is only running for 1,000 epochs. But basically what you're seeing is the score from the critic. The generative part sends recipes for the critic part. The critic says how good it is, and it goes up and down. But the basic story is it goes up and down, but like on a long term, it goes up. So it makes bad decisions, it makes the right ones, but at the end of the day, it will create something that's perceivably good, that's something that people could enjoy, and so on. We got the first reviews out. We've been sort of blessed with a lot of media covering the story, and people seem to enjoy it. In Sweden, we got it on the shelves 2 weeks ago on Friday. The whole batch was sold out in a day. So I think it's like, it's not a gimmick. We can actually do complex consumer recipes with machine learning now. We don't need to learn features and do the same stuff all over again. We can actually explore new spaces. And what I want you to leave you with, like, from this talk, is this is making whiskey, and this is like trying to make machine learning and sort of generative modeling approachable to people, and trying to figure out how we can sort of augment the creative process. But you don't need to stick to whiskey, or you don't need to stick to beverages or something like that. You can generate anything from sneaker designs to sliced bread with the same logic. And you can actually explore new stuff instead of just looking at the review mirror with machine learning. And I hope you got sort of enthusiastic about that from this talk, and I hope you will eventually have a taste of the product. So thank you.